Hello, everybody, and welcome to Hacker Rank TV. I'm Aditi, and I'll be your host for the day. As you can see, today we're joined by a special guest, a Hacker Rank All Star, and a data science maestro, Rhea Rodriguez. I'll introduce you all to her in just a second, but before that, I'd love to hear from all of you guys who are tuning in right now, because I know all of you are spread out all over the world. So, where you're tuning in from, which city, which platform, even, because we're streaming across LinkedIn, YouTube, Twitter, and Facebook today. Have you guys started your data science journey already, or is it something you're going to start after our live stream today? Tell us everything because we'd love to know. With that being said, I'm going to get started on introducing our guest for today, who I'm sure you're all excited to meet. So, DATA, data. These four letters have not just transformed the tech industry, but have revolutionized our world as a whole. There are business decisions, products, fields of study, and whole companies being built around it. And our guest for today, All Star Rhea, has mastered the art of working with these four special letters. After securing her bachelor's degree in India, she moved to Canada to complete her master's degree in computer science with a specialization in machine learning and data science from the Simon Fraser University. Since then, she's been working as a data scientist at the Royal Bank of Canada, where she wields data science to make banking easier for their millions of retail customers. Today, she's here with us to teach us a few things and help us get started with our journey in data science. Welcome to the live stream and our all star family, Ria.
Thanks, Aditi, and thanks, HackerRank, for this opportunity. Really excited to be here.
Awesome. So I know we have a really exciting tutorial scheduled today from Ria. But before we just dive into that, I'm sure you're all excited to hear from her perspective about her journey in data science, how she got started in it, and how you can too. So I've just got a couple of questions for Ria, and I know the audience probably has a few questions as well. So I'm just going to dive into these questions first before she gives us a tutorial. So, Ria, just to start us off and give us more context, can you tell us about your journey and your story with data science? Where and how did you begin, and how did you eventually become a data scientist?
Yeah, for sure. So, I was studying computer engineering. So during my undergrad, during the third year, I wanted to get involved in a research project. So I reached out to a professor, and she had published papers before. And she suggested, based on the papers she had written before, I take up a course on Coursera. It was the very famous machine learning course from Stanford. And at that time, it was very new. And I remember taking that course and really enjoying doing the math uh, behind it because it had been a while since I'd done that. And I liked that it made sense to me, and I found it super interesting because they talked about the applications this had in the real world as well. And then the next thing that happened was I started being on these online communities. Like there were subreddits for data science or machine learning. So I did a lot of uh, just reading people's experiences and answers and making up my mind that that's something I wanted to do. And then most of the people on that subreddit would say you need an advanced degree, you need a master's or a PhD. And so that's what I did next. I started my master's, specialized in big data. Um, the next thing I did was I got an internship as a data scientist, and then I got a full time offer at the same company. And I've been working as a data scientist, yeah, for a while now.
I mean, yeah, that sounds awesome. I feel like data science as a field especially requires a lot of specialization. So it makes sense that they suggested, doing a master's and getting a PhD because it's a really highly specialized area, but it's also extremely rewarding to work in, as I'm sure you know. So yeah, we have a lot of guests tuning in from LinkedIn, YouTube. I can see in my comments we have Fernando from Arizona. Hello and welcome, Fernando. We hope you find our live stream today useful and educational. We have Vijay from Tamil Nadu. We have Nathaniel from Karnataka. So, welcome everyone. Continue dropping in your comments and questions. I'm super excited to carry out this live stream today. So, yeah, jumping to my next question for you, Ria. We'd love to know more about specifically your role as a data scientist at RBC. Now, you've told us that you started off as an intern and then you got converted to full time. But how has your life as a full time data scientist at RBC been so far? What do you work on the daily? And, if you could just let us in on what's the best and the worst part of your job, just so any aspiring data scientists here know about it.
Yeah, so for those who don't know, RBC is a private bank over here, so a financial institution. And it's a huge organization. There's so many different verticals and departments, and it just depends where you're at in the bank. Um, so I've worked on a couple of different projects. Um, like I said, it depends on the team you're on. I've worked on projects for retail clients, so people like me who have credit cards. I've done a project with wealth management, and currently I'm working with cybersecurity, so data science for cybersecurity. And to answer your question about uh, what the day to day looks like, it's a lot of different things at different points of time. So if I'm at the start of the project, it's more of like understanding the problem we're trying to solve, having meetings with the business, um, figuring out if we have the data available to solve the problem. Do we need to go out and get it from a third party or even from a different team at the bank? And then you start spending time with the data, understanding it, uh, making your like preliminary analysis, start forming a hypothesis, and then you're like doing the exciting stuff, which is the modeling, and then you get to test it, evaluate performance, and again go back to the business, show them what you've been able to accomplish, and it's a very iterative process. So you go through the same process a couple of times. And in terms of what's the worst and the best part, I think um, everyone has their preferences, and I'm not particularly fond of getting the data part at the start. And although it's a very important thing and it can be interesting, you might find stuff that's surprising, even shocking sometimes. And it can completely invalidate a hypothesis that you had, what you find in the data. But yeah, I'd say that's my least favorite thing to do out of everything. My most exciting thing I find is the modeling, and yeah, the yeah.
Yeah, I mean, I'm pretty sure a lot of data scientists who are tuning in today or people who are learning data scientists can relate to that. I mean, I myself have heard it from a few friends of mine in data science that they really dislike, the initial data collection part of the whole process. But
Yeah,
yeah,
I mean, I don't dislike it, but like I said, it's like the least exciting part. Yeah,
yeah, yeah. Makes sense.
it's a part
I
of
think
the job description.
Yeah. I mean,
Yeah.
yeah, as you said, there's going to be a good and bad parts of every job. But, I'm guessing you find this job at least majorly good to continue with it and like be
Oh, yeah,
excited
for
by your
sure.
daily job. Yeah. Awesome. I see that we have a couple of questions already from the audience. So if you don't mind, Rhea, do you want to take a few questions? Because I see a few interesting ones
Yeah,
here. Okay,
let's do it.
awesome. So we have Vamshi. Vamshi, welcome to the live stream. I'm guessing he's asking if Python and data science are just the fastest growing domain in tech in general, because the world of tech is just really vast. So I'm guessing he's asking, is it the fastest growing career? So what's
Uh,
your thoughts here? What are your inputs?
yeah, hi Vamshi, thanks for your question. I don't know about if it's the fastest. There's a lot of exciting things happening in tech these days, but I'd say it's kind of new, and there's a lot of work that needs to be done still. There's a lot of potential over here to do new things. There's a lot of cutting edge research that can be applied in the real world. So I'd say it's definitely new, and there's a lot of room for growth and just so much potential for the next few years, actually, decades. Yeah.
Makes sense. Yeah, I mean, I completely agree from what I've read online and what I hear from people. There's so much potential in terms of like the applications for data science that we haven't even, touched the surface with yet. So it's definitely an exciting stream to be in right now. We have another LinkedIn user who's tuning in, and he's asking how to get started with machine learning as a beginner. Now, I know you're going to be covering this in our tutorial today and later on in our questions, but just to like touch the surface, what would you like to say?
Yeah, so machine learning as a beginner, I'd say start uh, going through, even if it's YouTube videos, start being a part of online communities, if that means Koya or being a part of subreddits. Kaggle has a great online community as well. If you can find in-person meetup groups, if you don't have a lockdown where you are, that's great too. So just finding people and working together, I think that helps.
Makes sense. I mean, I think just learning anything to get started with it and to stay motivated throughout it, it's always better to just either have a study buddy or a study group or just people you can do it along with.
Yeah.
So, yeah, I hope you got a few insights to get started with ML. We have a few other questions, a lot of other questions actually from the audience, but I'm gonna save that for during the tutorial and later because I know we want to get started with this and a lot of people are excited for it as well. So Ria, if you want to go ahead and share your screen and get started with that, that would be great.
Okay. See. Um, okay, I'm just gonna put it in. Alrighty. And now share my screen. Mm, share screen. Can I share a single window? I think I can. Yeah. Can you see
Awesome.
the
Yep.
slide that says introduction?
Yep.
You
It's
do?
on the screen. Yep.
Okay, cool. So let's see. Okay, yeah, like Aditi mentioned, we'll be going through a example in a couple of minutes. But before that, I just wanted to walk you through a couple of slides to get an idea of what data science is, because I'm assuming you guys are new. So to find out what data science is, I went to Wikipedia and got a definition, and it says data science is an interdisciplinary field that uses scientific methods and processes to extract knowledge and insights from data. And I think this definition is 100% correct um, and perfect, and it makes complete sense to me. But I think we can find a more fun definition on a more fun part of the internet. So I went to Twitter to find out what people were saying about data scientists and what data scientists do. Okay. Um, this one is completely false. You don't need a specific operating system. You can do data science on any platform operating system and even with the cloud providers these days. Um, Again, this one's like half true because you can do the data science work from anywhere in the world with a stable internet connection. Um, and I think the point over here that I like is that uh, a data scientist is a statistician, and I think that's true to a very great extent because you are doing statistics in the data science process right from the beginning, in the middle, and at the end. So you have to have knowledge of statistics. And now this one is my favorite definition. So it says a data scientist is a person better at statistics than a software engineer and better at software engineering than a statistician. And I think the point that this definition is trying to make is that until very recently, we didn't have a formal description for a person doing data science work. The title data science is so new, and it only came up in the last decade, so the 2010s. And the reason data science sort of exploded in the last decade is that people all over the world started carrying a smartphone on themselves. And what this did is it gave companies access to a lot of data about people all over the world. And they were able to play around with the data and experiment with the data to build models. And this was something that was not possible in the previous decades. And we just didn't have access to that kind of uh, data sets. And another point to make here is that data science work is not new. It's been researched and studied since the 1950s, actually. And the problem over there was that it was not feasible to put a model into production because it was not a useful model. The accuracy was poor. It was a crappy model because we didn't have enough data points to train on. And that really changed, like I said, when the smartphone became ubiquitous. So companies could build more useful models that had higher accuracy. And with that history lesson, I'm going to show you another comic I really like. And this one's a little bit funny because there's an element of truth here. And the truth is that we've been using statistics for hundreds of years. And according to Wikipedia, statistics was recorded earliest in the 18th century. And um, what helped again drive the popularization of data science in the last decade is not only the smartphones, but I think how cheap and accessible computing became, which just means that companies and universities were able to afford faster processors and GPUs, using which they could train models faster and train them on even larger data sets than before. So that access to cheaper computing took these machine learning models out of the research labs um, and into applications like fraud detection, facial recognition, and recommendation engines. Um, Another point I want to make is that this rise of machine learning and artificial intelligence only happened because we had access to all this computing power in the last decade. And I don't want you to think of machine learning or AI as a rebranding of statistics or AI as a rebranding of machine learning. I think they are all different tools. And as a company investing in technology, you want to have different tools in your toolbox so that when you have a problem that arises, you can look into your toolbox, pick up the most appropriate tool to tackle your problem. Um, and I think that's why being a data scientist is so exciting because you get to decide the problem you care about, the problems you're passionate about, and go learn the tools and techniques to be able to solve that problem. Like I mentioned, these are the just different tools in your toolbox. And my personal favorite one is machine learning, and it's how I got started with data science. And that's something I want to talk about just for another minute. So again, I went to Wikipedia, got a definition. It says ML is the study of computer algorithms that improve automatically through experience and by the use of data. And I don't have any funny comics over here, but an analogy I want to make is that of a child's brain. So when a child is learning about its environment, it's gathering more and more data points, and over time, it's able to uh, become smarter. And that's a very loose analogy for what you can think of as machine learning. And yeah, okay. So we're going to do the Titanic dataset problem on Kaggle. And Kaggle is just another platform like HackerRank, but specifically for data science problems. They have competitions, and like I mentioned, there's a very active community over there, and they're always posting solutions and interacting with each other. They also have a lot of learning resources if you want to check that out. But yeah, so Kaggle has this Titanic dataset problem. It's like the calculator project you do when you're starting out with a programming language, but for data science. And what it asks us to do is predict whether any given passenger on the Titanic will survive or not. And it gives us a bunch of data points. So we're given all these data points, and what we need to predict is whether someone survives or not. So we have something called the passenger ID. Survival is basically, does a person survive or not? If it's one, the person survives, and if it's zero, they've died. So we have a bunch of other features, but the ones we are going to use are going to be whether a person survives or not, the passenger class, which is just does a person belong to first class, second class, or third class. Now, gender, is a person female or male, and then we have finally age, which um, is a person a child or an adult. And I'll show you in the code that I'm going to consider everybody over the age of 18 an adult, and uh, under 18 is going to be a child. And I'm going to hypothesize that we'll be able to predict whether or not a person survives based on three things. So, based on their age, based on their gender, and based on which ticket class they belong to. And I'm going to stop over there, and I'm going to share my notebook, and I'm going to also pause.
Yeah,
Uh,
so Ria, we have a couple of really interesting questions just on
okay,
ML and
let's
data
do it.
science in general. Yeah, before we dive into the Titanic data set. So Priyanka asks,
Yeah.
and I think this is relevant to how you mentioned people tend to rebrand AI as ML or data science as ML, and it can be confusing. So she asks, can you let us know the difference between ML and data science, maybe with a real world example?
Okay. So I think data science is a more umbrella term for what a person does. And when you say someone's a data scientist, they might be doing machine learning, they might be building models, uh, they might also be doing deep learning. It depends on the problem you're solving. Um, and I think companies are also confused about what to call their job roles because it's such a new thing and there's so many different um, you know, activities to be done. I think the lines are blurry and I don't have a great answer for this except that machine learning is one thing a data scientist can do. uh, yeah.
Makes sense. Yeah. Thank you for
Yeah.
taking on that question. And obviously, we'll gain more insight into this as we move on to a real world example that we'll be tackling, which is the Titanic data set. So, we have another question from Sankara. Sankara, thank you for tuning in. So, it looks like Sankara is a beginner in data science and Python, and he's explored these parts of Python, which is NumPy, Matplotlib, Seaborn, Keras. Are they enough? Is it enough to know some basic algorithms in ML and the Titanic project? Is this enough to land a data science role, or what else do we need to do?
uh, Hi Sankaya, I think that sounds like a lot to get started with. um, and eventually, yeah, you'll be able to learn all those things over time. um, so I think you're on the right track. And if I could add one thing to that, I'd say add a little bit of statistics, like a little bit of statistics knowledge will really help.
Makes sense. Yeah. Thank you for giving us that insight. Just one more question before we get started from Silky. There's a very important question to tackle, I think. She says she also did her master's in data analytics and built many machine learning models. for the predefined problems. She wants to know, in the real world, is neural network being used as much as we hear about it? Is there a problem in interpretation of the layers and model as it's a self-learning model, and how is it being handled in IT? So a pretty heavy question. If you want to tackle this in parts, feel free to. But yeah,
I think it's a great question. It's a very good question to ask. And okay, there's a bunch of things over here. So, is the neural network being used as much as we heard about it? Yes. It's not called a neural network. They're usually called deep learning algorithms, which are just like neural network with hundreds, if not more, layers of neurons. And yeah, there is a problem in interpretation of the layers because it's essentially a black box. You don't know what's happening inside. Um, and there have been companies that have come up who try to solve this problem of explaining these black boxes. Um, you can never know for sure what's happening inside, but they try their best. There's a lot of research as well to try and explain what's happening inside. But yeah, so that, and then what's the last thing is a model. It's a self-learning model. So how's it being handled in IT? Um, is it a self-learning model? Yeah, in a sense, you just give it inputs and outputs, and it's able to detect patterns and make correlations in the data, right? Um, I don't know what that last question you're trying to ask with that last part, but yeah, it is self-learning. Um, yeah.
got it. Silky, I'm sure Ria has tackled your question mostly, but if you have any further doubts or anything, please feel free to leave a comment and we'll take it on later. So I also see a lot of questions about, I'm a beginner and, is it worth learning data science? Is it worth starting now to make a career switch? How do I begin? And all great questions, guys. We'll be tackling it just after Ria walks us through this Titanic project. So yeah, Ria, feel free to share your screen and we can get started.
Yeah. Okay. I'm gonna close the presentation, and where is, okay, I think, I'm sorry, I'm just gonna open it one more time. Okay. Share screen, where's the share screen? Okay. Share a window, and I have this, okay.
Cool. Awesome.
Okay. So, can you see this? The
Yeah.
import and view CSV. Okay. I've also given Aditi a link that she can share to the GitHub notebook or the Jupyter notebook on GitHub. So yeah. Okay. So let's start. So I've already gone and downloaded the data set from kaggle.com, and I'm going to import it into this notebook using something called pandas, which is a Python library for handling data sets. And this is what our data looks like. So we have the passenger IDs, whether or not a person survived, the passenger class, so does a person belong to the first class, second class, or third class, the passengers' names, the gender, so whether they're female or male, their age. This is just the number of siblings a passenger has. And this is the number of, I think, parents that's traveling with the passengers. I'm not sure, but you can go and check that on kaggle.com. They have a data set description. Ticket is just the ticket number, fare, like very self-explanatory. Cabin is probably just the cabin number people were assigned, and embarked. I'm not sure actually what that is, but I'm sure we can find that on Kaggle. But we're not going to focus on that. Like I mentioned, we'll be using the passenger class, gender, and age in order to predict whether or not a person survives. So moving on. So Pandas has a very useful thing called this dot describe method, which just lets you view a bunch of stats at one glance. And what we can see right now is there are a total of 891 passengers. Um, and if we look at the survived column, we see that the mean survival rate is 38% because ones are survived and zeros are did not survive. And if we look at age, we have only 714 values in the age column as opposed to 891 totally. And what that tells us is we have a bunch of age values that are missing. And we decided we're going to be using age to predict survivability. So we need to do something about those missing values. And that's called feature engineering, and that's what we're going to do. Yeah, so like I said, age is going to be a predictor of survivability. So we're going to have to handle those missing values somehow. Okay, so if you've noticed, every passenger's name either had Mr. or Mrs. Um, or some honorific. So when maybe people were filling out their forms to uh, board the Titanic, they had to, you know, give their honorific. So we have that information, and I'm going to propose that we use that information to go and fill in the missing age values. So I'm going to extract those honorifics, and these are all the unique ones we have. We have some very weird ones over here, which I'm going to map to fewer honorifics so that um, we don't have any outliers. So, for example, lady becomes lady, the countess also becomes lady. And I've done this for every single unique honorific that we have. And when I go and plot the median age for each of those honorifics, this is a box plot which shows me the medians. So, for example, we have lady, master, miss, Mr., Mrs., serviceman, and sir. So, the median age for a lady is 41 years, for example, and for miss, somebody with a miss in their name, it would be 21 years of age. And by the way, these dots are just outliers. So, just so you know. Yeah, and then for example, somebody who has Mrs. in their name, their median age is going to be somewhere around 35, and so on. So if I have a person who is a lady with a missing age value, I'm going to say let's replace that missing age value with the median age value for a lady, which is around 41. And that's what I'm doing over here. So I'm going to replace, sorry, going to replace the missing age values with the medians we found in the box plot. Okay, we need to fix the gender variable because right now it just says female or male, like we saw at the start. And a machine learning model doesn't understand strings. You need to give it numbers, numerical values. So if someone's a male, I'm going to say 0, and if someone's female, I'm going to say 1. So we're just converting the categorical values over here into numeric values. Okay, now we've cleaned the age column, so we have no missing values anymore. We're done with gender, we have only numeric values, no categorical values. And our passenger class had values 1, 2, and 3, which is fine. They're numbers, so a model is going to understand that. And now we want to do some analysis, go look at some plots and make sure that what we're hypothesizing is actually going to work out. So let's see the survivability based on passenger class. So let's again, zeros are the people who did not survive, and ones are the people who survived. So if we just compare these passenger classes, we see first class passengers survived way more than any of the other two classes. Um, the most number of people who did not survive was in the third class. So that tells us that, yeah, there is some signal between um, a passenger class someone belonged to and whether or not they survived or not. Let's look at gender. So if we see, again, zeros are the males and ones are the females. So the number of males that did not survive is way higher than those who did survive. Whereas if we look at females, the number of females that did survive were more than double the number of females who did not survive. So the survivability depends on whether or not you're a female or a male. So we are going to be using it, and that's a good indication that that makes sense to use. Okay. This one, like I said, age. So how do we decide someone's an adult or a child? I've just taken the threshold of 18. So if someone's 18 or older, I'm going to say they're an adult. And if we look at the plot, the number of children that survived uh, is slightly more than the number of children who did not survive, whereas it's the opposite for adults. More adults died than they survived. And I think this is another reason to believe that age is a determining factor when it comes to survivability. And I did this analysis for all the other features we saw at the start, and I haven't shown it over here, but if you do that, you'll see that those features don't have such a strong signal when it comes to determining whether or not a person survives. And when you see that, you can safely say that, okay, I'm not going to use those features. I'm just going to drop them and keep the ones with the strongest signal. And that's what I've done here. So we're going to keep the features that we just saw and drop everything else. So passenger class, gender, and age. And now, okay, it's getting exciting now because we're going to start actually building the model. And for this, what we want to do is use scikit-learn, which is a machine learning package in Python. So it has a sort of a library of models already ready to go. You just need to import it and call it. And the way that works is you have to follow certain rules. And one of the rules of scikit-learn is we need to split our labels and features into different data sets or data frames rather. So that's what I'm doing here. So my features are the three features that I had. So the age, gender, and passenger class. And my labels are whether or not a person survived or not. Another thing we need to do for scikit-learn is divide this into a training set and a test set. And why isn't it going forward? Okay, yeah. So I'm going to say let's split this into a training set and a testing set with a test set size of 25%. So 25% of my data I'm going to set aside for evaluating my model. And I'm going to train my model on 75% of the data. And uh, what this means is that our model is not going to have access to the 25% of the test set, which means when we make predictions on the 25%, we're getting a fair, performance metric or a fair evaluation of how our model is doing. So this is how scikit-learn works, it's very simple. All we need to do is call a decision tree and give it the inputs and the outputs. So the inputs are nothing but the features we selected, and the outputs are the labels, so the zeros and the ones, whether a person does not survive or survives. And yeah, we get this very simple decision tree. It has all the default hyperparameters, nothing fancy. It's a very simple, plain decision tree. And where is it? Yeah. Now to evaluate this, like I mentioned, we'll evaluate it on the 25% data from the testing set that the model has not yet seen. So the way we do that is, again, call a scikit-learn function called accuracy score, give it our labels, the actual labels and the predicted labels. And we get an accuracy score of almost 75%, which isn't great, but given the fact that it's a very simple model, we didn't do any hyperparameter tuning, and we have only three features, it's quite decent, the score. Okay. I want to show you how the tree looks because that's the good thing about a decision tree. You can um, visualize it. Okay, that's a huge tree. Um, I don't know if you can see the whole thing, but it's very, very deep. There's so many layers to this. And um, what this actually is called in machine learning is something called overfitting. And overfitting is not a good thing. It just means your model has memorized the answers. It's not able to generalize to data points it has not seen before. And one way to handle overfitting is to decrease the depth of the tree. And you decrease the depth of the tree setting a hyperparameter called depth. And that's what we're going to do now. So I'm going to say let's set the maximum depth that the tree can grow up to be 3 and fit the same input. So 75% of the data that we saved initially use the same data to train the same decision tree, except the depth is going to be set to 3 now. And let's do the same thing with testing the model. So using the 25% of the test set to get an accuracy score, and it gives us a score of 79, almost 80%. And we got a 5% improvement just by setting a depth of 3, which is quite a significant improvement in performance. So this is what it looks like with only 3 layers of depth. And it is definitely not overfitting as much as the previous one. And I'm going to stop over here. And you always have the link to the GitHub Jupyter notebook over there, and you can go through it on your own. And for now, I'm going to stop here and take any questions if you have any.
Yeah, thank you, Rhea. I mean, that was really insightful so far. Thank you for walking us through it, and we're excited for the rest of the demo. We have a couple of questions and one funny comment that I want to highlight. We have Aditya Pandey from LinkedIn.
Oh,
Thank you for tuning in today, Aditya. He said this
yes.
problem should be dedicated to Jack, who didn't survive. And yeah, that's a very insightful comment, Aditya. That makes sense.
Yeah,
We
I'm
will
gonna
dedicate.
go. Yeah,
Yeah.
I'm gonna go and make a change to the GitHub README. I'm gonna add that dedication.
Yeah, I mean, let's just say we're dedicating this live stream today to Jack
Oh yeah,
because, yeah, I
that
mean, this
too.
is really, yeah, awesome. So we have a couple of other questions. One interesting question we got from Mariankela Tafuri. Thank you for tuning in today. For this Titanic data set, it might have been better to use Cox's survival model. Is it possible to use machine learning with survival models? So, do you have any insights there, Ria?
I am not aware of what Cox's survival model is, so I can't answer that question. But I'm very excited to go and Google it after this live stream. Yeah.
Yeah, absolutely. I mean, Mariangala, if you have any insights that you want to share with us in the comments about the Cox's survival model, please feel free to go ahead. I mean, we're all here to learn today. So, yeah, we have a couple of other just general questions that are pretty interesting about like applications of ML and how to get started. So, I'm just going to bring a few of those up. Lakshay Gupta from LinkedIn. Today, he asks, how will machine learning be used in this new era of blockchain? So, are there any real world applications that you can shine some light on, Ria, about data science in blockchain?
I'm not aware, to be honest. I'm not aware of how blockchain works and what app. Yeah, I can't answer that question.
That's okay. I mean, anyone else in the comments who's tuning in today, please go ahead and just, let us know if you're aware of any novel uses of data science and blockchain. It is an emerging field and it's really exciting. So we'd love to learn about it as well. And lastly, we have Priyanka. So I think she's addressing how you mentioned in the beginning, it's better to join a community or study groups to get started in data science. Are there any communities that you joined when you got started with data science? Do you recommend any, I don't know, be it Discord groups or official study groups that people can join?
Okay, so when I started, um, I remember being on subreddits a lot. So there were data science subreddits and machine learning subreddits, reading answers on forums. It was very one-sided, to be honest. The only place I found where people were actively discussing stuff was Kaggle. So yeah, I'd say, but then again, I think today there are so many Discord servers and communities online. Uh, and it's easy to get lost in all that, but experiment, try a few of them and find whatever sticks, whatever you think you can stick with. Yeah.
Yeah, I mean, I feel like subreddits are a gold mine of just
Oh
information and
yeah.
knowledge for just any subject, like in the entire world. So yeah, definitely check those out, Priyanka. Yeah, we have a few other questions, but I think I'll bring it up after you walk us through the rest of this demo.
Oh, we're done. Like this
Okay.
was our model that we built. Do you have any questions?
Yeah,
Though,
I mean, there
like,
are
does it
a
feel
ton.
incomplete?
No, it doesn't. My bad. There are a ton of other questions. So I'm going to go ahead and
Okay.
bring that up. Awesome. Okay, so we have Visarda Kumar. Thank you for tuning in today, Visarda. So he says, I'm 3 years into the field of machine learning and data science, and I'm still understanding the basics of deep learning models such as RCNNs, faster RCNNs, and other CNN architecture. Now come the transformers. I'm sorry if I'm butchering the pronunciation of this, by the way, but Bayesian deep learning models. It's intimidating and overwhelming for a person who's new to it. So, what are your suggestions? How do you go about learning this and getting past that initial barriers?
Yeah. I think I still get overwhelmed by how much I don't know. It's not possible to know everything, right? And you just take it one step at a time. Um, do your fundamentals. Yeah, just have a strong knowledge of the fundamentals, and by that I mean statistics, a little bit of how to program and write code nicely, and of course your machine learning algorithms, and a little bit of what it's like to go and apply that in the real world. So maybe do a little bit of hackathons or competitions. Um, and I think over time, maybe you will figure out what you need to learn to solve a problem. Like, I don't know everything, but I know that if I have to solve a problem that comes to me tomorrow, I can go and brainstorm with my team or go online on the internet and see if this problem or a similar problem has been solved before. And if it says Bayesian deep learning is how this is going to be solved in the best way, I don't know anything about Bayesian deep learning. So I'm going to go and take some time, uh, find a few research papers, maybe find a few blogs, watch a couple of online videos, maybe, and understand it, and then go and do the work. So, yeah, you don't have to know everything, and it is overwhelming, and you're not alone.
I mean, yeah, I think that's a powerful takeaway from this for anyone who's watching. It can be overwhelming, it can be intimidating, however deep you are into data science or if you're just getting started. But yeah, important to remember that, no one really knows everything there is to know, and all that really matters is the progress you're making. So yeah, I think with that, I think we can take a break from the serious stuff. We've learned a lot. We've gone through a tutorial. We've answered a bunch of questions that you guys have. So right now, what I'm gonna do is I'm gonna introduce a fun segment that we have on our All Star live streams, which we like to call Tech Talk, which is TECH Talk. So basically, I'm going to be throwing a bunch of like vague data science concepts at Ria, and she has to explain it to me like I'm 5 years old and in just 30 seconds. I know that's going to be pretty challenging, but I know Ria is up for it today. So, let's just get started with that. Are you feeling ready, Ria?
Just let's do this.
Okay.
Yeah.
Awesome. Okay, without any further ado, just gonna throw the first one at you. So, regression models.
Okay. Regression models are the opposite, not the opposite, but sort of the alternative to what we just did. So, what we just did with the Titanic problem was saying, uh, does a person survive or not? Yes or no, ones and zeros. That's binary classification. You have only two outcomes. A regression is when you have a continuous value you want to predict. So, a very popular problem over there is predicting house prices, for example, based on number of bathrooms, number of bedrooms. You're predicting a continuous dollar value, for example. Yeah. Okay, next.
Okay. Got it. I mean, I'm really trying to get into the mindset of a 5-year-old here and just trying to evaluate if I got it clear. And I think you did pretty well there. Okay.
Thank you.
So next would be something we've been discussing so far a lot on this live stream, just machine learning.
Machine learning. Oh my gosh. How do I explain this to a 5-year-old? Mm, uh, let's say, uh, hmm, I'd say it's more like it's a lot like how a 5-year-old's mind works. Like, how is a 5-year-old able to tell the difference between uh, a red apple and a red ball, for example? Maybe they can tell the difference when they are five, but I don't think you could tell the difference when you were 2 years old, maybe. So you've learned over time, right? Collected a lot of training data. I'm sorry, but 5-year-old, yeah, that's my best explanation. 5-year-old.
Yeah, no, I mean, I think that works for sure. Thank you for that. Next, we have neural networks.
Okay, neural networks. So neural networks, you can think of it like this black box with hundreds of connections and hundreds of tiny calculations happening, and you don't know what's exactly happening at any given connection or point of time. Um, and what this black box tries to do is associate certain inputs with certain outputs. Um, yeah, so it's trying to just bridge the gap between inputs and outputs. Yeah.
Makes sense. I mean, I think for some mid-segment encouragement for you here, Ria, we have Sanskar tuning in from LinkedIn, and he says he's 5 years old and he confirms that he's understood this. So yeah, I mean, you're doing great.
Thank you, Sanskar.
Only a, only a couple more to power through. So the next one we have for you is big data.
Big data. Okay. I want to say uh, it's exactly what it sounds like, except like multiplied many, many times more. in size. So it's a lot of data that you collect from different sources that come in different formats. Uh, yeah, like it's just this whole mess of data is what it really is. Yeah,
Yeah. Makes sense. Yeah. Thank you for that. Last one. We're done with this segment, Ria. So
Aditi,
we have,
I
yeah, sorry.
okay, cool. I got you back. No, I thought I lost you for a second, but yeah, you're back.
Okay. Yeah, I mean, it looks like my internet is acting up as usual. So, for the last one, we wanted to get one from the audience. So, if any of you guys have any concepts that you're confused about, or you just want to have fun with and have it explained to you like you're 5 years old and you want Ria to explain it in 30 seconds, please go ahead and drop it in the comments. But while you guys are doing that, I'm going to address a couple of other questions that have come in, a couple of interesting and great ones. So, Priyanka from LinkedIn, she asks us, can you tell us a little about the educational roadmap? Because as we introduced you, you first did your bachelor's degree and then a master's degree specializing in data science. So she asks, is a bachelor's degree enough? Or, is it absolutely necessary to have a master's degree to get started in this field?
Mm, it depends. Uh, it depends really on the kind of role you're looking for, um, the kind of company even that's hiring. For example, it depends. I think my answer is just it depends, but I want to say that yes, a bachelor's degree should be enough, uh, because you can always study on your own on the side and build up a portfolio or side projects, even if that means having casual, competitions that you've done. uh, yeah, I think it's enough. A master's degree doesn't hurt, obviously. And I think there's a bunch of different ways you can bypass a master's degree. You can start uh, in a company and then always transition into a role that you want um, to move into eventually. So yeah, sure, yeah,
Awesome.
it depends.
Thank you for shining light on that, Ria. So I see a lot of comments actually asking about the GitHub link. So what I'm gonna do is I'm just gonna flash the banner here again. I think Sanskar has dropped it in the comments on LinkedIn as well, so you guys can just go over there and copy and paste it in your browser. And while you guys are doing that, I have a couple of other questions for you, Ria. So yeah, I think this is just about data science as a profession in general, right? Because as someone had brought it up earlier in our live stream, it's a really fast growing field right now, and there's a lot of potential in terms of application. So yeah, I mean, it was even called the sexiest job of the 21st century by the Harvard Business Review all the way back in 2012. So according to you, is it still enticing, and can you shine some light on what would be your favorite particular application of it? Because it's used in advertising, healthcare, virtual assistants like Siri. So if you could just give us some of your thoughts there.
Is it still enticing? Um, I'm obviously biased because I am a data scientist, so I'm going to say yes. Um, and I think that's why I continue doing it, because it is something that I find personally very not only exciting to do but also impactful. And like you mentioned, yeah, there's so many different applications in marketing and just those virtual assistants and everything that we've been hearing about. I think there's, like I mentioned, it's new and there's a lot of problems to be solved and a lot of room to build these new applications and improve them. Um, and I think as we go on getting better infrastructure, even a better compute, um, collecting data better, faster, we're only going to improve our models and the applications we have.
Makes sense. Yeah, absolutely. Thank you for sharing your thoughts there, Ria. I think it's about time that we can conclude our session. And to do so, I just wanted to end it on what are your top three pieces of advice for those who would like to start their data science journey after this live stream? So, as you saw, there were a lot of beginners, a lot of students who were curious on how to shift to this career. So, yeah, just your pieces of advice for them broadly.
Um, I would say, um, make sure you're interested in this, and the way to sustain your interest, I think, is being a part of, like I said, a community. Or just, you'll realize that, okay, you're the one going on to the internet looking for blogs or more information about this field. And if you're doing that organically, I think that's a great sign that you want to do this. um, so make sure that is what you want to do. um, what other things I want to say? I would say, uh, obviously, I've mentioned this before, but I think statistics is really important. Of course, if you have a statistical background, you might want to focus on something like uh, how to write good code, clean code, modular code. Um, yeah, it just depends on your background. Figure out what your strengths are, try to work on those strengths, figure out what you don't want to do as well, because that's just as important as deciding what you want to do. And yeah, I think start working on projects, and even if that means just having a GitHub repository with different projects. And I've seen a lot of people with these projects, but one thing I like to see is the person's documentation of how they approach the project. So try to explain it. If you want, try to explain it to yourself. Record yourself in a video and tell us why you did what you did, what motivated you to solve this problem. I think, uh, yeah, those are my three things, uh, tips, whatever. Yeah, advice.
Yeah, I mean, I think that was great. Just to summarize it, make your projects, document it as well, try to explain it to yourself, and most importantly, know what you don't want to do because, that can be just as important as knowing what you do want to do. So, thank you so much, everyone, for tuning in. I see a bunch of comments coming in about how this has been a really useful session, a really educational session. Alkesh says he wants a daily 1 hour session like this. So, not sure if we can make that happen, but thank you. We really like the fact that you enjoyed the session today. With that, I think our session is over. So, thank you so much, Ria, for joining us today. That was really great and very educational. And I think I learned a
Thanks,
lot
Aditi.
myself. Yeah. Thank you, all of you guys, for tuning in, for engaging with us throughout the live stream, asking us really awesome questions. We have a bunch of other Hacker Rank TV live streams coming up with all stars as well as other companies. So thank you guys. I'll be seeing you soon. Thank you. Bye bye.